Good morning, students. I am Mrs. P. Balachandra, Assistant Professor, Department of ECE. Today we are going to discuss about Introduction to Verilog in Hardware Description Language. So, Verilog HCL was invented by Philip Morby and Prabhu Goyal around 1984. It served as a proprietary language by Gateway Design Automation. Actually, it is modified in all the revision that came between 1984 to 1990. In 1990, the Gateway Design Automation was acquired by Cadence Design System because it is one of the largest supplier in electronic design technology. That is, they have serviced the electronic design automation industry today. So, in 1991, the Open Verilog International was organized by Cadence and documentation of Verilog was transferred from proprietary domain to the public domain under the name of OVI. Then it was transferred to IEEE. In IEEE standard 1364 and 1995 commonly referred as Verilog 95. In 2001 it was extended and to be submitted to the IEEE back and it becomes 1364-2001 as known as Verilog 2001. In 2005, the Verilog 2005 was published with minor correction and modification. So after 2005, the System Verilog and Verilog language standard were merged into a System Verilog 2009 and it is one of the popular language for IC design and verification today. So Verilog has HTL. So the Verilog have variety of construct as a part of it. All are aimed to provide a functionally it was tested and verified the design description for the target FPGA, that is field programmable gate array, or ASIC, that is application specific integrated IC. So the language has two dual functions, right? One, fulfill the need for the design description. The other will fulfill the need of verifying the design for its functionality as well as the timing constraint like propagation delay, critical path delay, slack, setup and hold time. So the Verilog HTL have different level of design description. So it help to construct the Verilog language. It's very easier one. So the level of descriptions are circuit level, gate level, data flow level and behavioral level. So first we are going to discuss about the circuit level of design description. At the circuit level, so the switch is a basic element which is used to design a digital circuit. So switches can be combined to form inverters or the other gates for a higher level. So Verilog has a basic mass switches built into its construction. So it can use to build the basic circuit like inverters or flip-flops or simple dynamics or static memories. So by using the switches and we can design a RAM and ROM also. So next we are going to discuss about gate level design description. So it is the next level abstraction to design a digital circuit by using in terms of basic gates. So all the basic gates are available in a ready module called primitives. So all the primitives is defined which is in terms of its inputs as well as the outputs. So the primitives is incorporated into design description directly because we have lot of gates will be available. So all the readily available gates will be mentioned in terms of a primitives. For example, AND gate, OR gate, NAND gate. So we have a OR gate, XOR gate and NOR gate. So all the gates are available, readily available in gate level design description as primitives, right? So just a physical hardware can build by using these gates. So actually the primitives can be used repeatedly and to build a larger circuits. And next one is the data flow level of design description. So it is a next higher level abstraction. So all the possible operation of signals and variables we have to represent which is in terms of assignments. Actually we are representing our assignments which is in terms of equations. So all the logic and algebraic operations are here we have used over here. So assignment will be defined in terms of a continuous function of blocks. So at the data flow level, the signals are assigned to the data manipulating equation. So we are representing a digital equation which is in terms of data flow level. Right? All the assignments are concurrent in our nature. The next level, Next is the behavioral level of design description. So it is essentially it is a system level itself, and the assignments, all the assignments will be in terms of construct by using the C program level, and the statements are involved are dense in functions, and it is a compactness and then comprehensive nature of a design make a development process fast and efficient. So all the constructions we are using, which is in terms of C program, it is if loop, case, and all the statements will be we can use over here to design a digital circuits. Next one is a concurrency, right? So in the concurrency, actually we have a voltage and current different elements we have to use in our digital circuit, right? So we have to, the logical levels also we can change it, right? So it is also possible over here in a HTML language as in a concurrency operation. So the number of activities may be spread over a different module to run the concurrency. So Verilog simulator also built to simulate the concurrency. Next one is a simulation and synthesis. So actually the translation of debugged circuit and into a corresponding hardware language will be called as synthesis. By using FPGA and ASIC, we have to convert our hardware circuit into a synthesis. The tools which is related for the synthesis is more easily the gate level as well as the data flow level module. The circuits realized from them are essentially direct translation of function into a circuit level. So we have different package will be available, right? So the gate as well as the data flow levels are combinedly we may commonly used as RTL level, that is resistor transistor level description. So next one is, we are going to discuss about the functional verification, right? So it have a two dimension. One is a functional test, another one is a timing test. So both will be carried out in a Verilog language, right? So in the functional test will be carried out by test bench, and the test bench have design will be instated in the coding itself, right? So we have to generate a test signal and we have to apply the instated design. The output from the designs are then back to the test for the further analysis. And the test benches for test inputs for test benches. Once we have to design when we have to design a circuit, right? So we have to test for all the functional aspects, and we have to test the inputs for combination or a different periodic and a numeric sequence, or we have give a random inputs or a combination of this also we have to give and test our circuit, right? So such a test have two type of observation. One is we have to study a signal within a small unit, and we have to then we have to test into a whole unit also, right? And we have to isolate a small unit, or we have to make a local test to facilitate the debugging. Next one is a very important topic in our Verilog module. Verilog is the module, right? So the module is a very important, it is a black box of our Verilog HTL, right? So we have input port as well as the output port. So this is our input port, and we have module, and this is adder, and A, B, P, Q, X, Y. So here A, B is nothing but input port, and X, Y is nothing but output port, and then A, P and Q is nothing but in-out port. So first initially we have to mention the output port, then we have to mention the input port. So the module given, already I told you it is a block box of input as well as the output terminal. So the modules will be referred as in terms of a ports, right? So the ports have three types. One is input ports and output ports and in-out ports. So input code it should be entry into the module, and output is nothing but exit the module, and out is nothing but we can entry as well as the exit from the module. So the modules have the terminals are through which the inputs and outputs we have to transfer in our module, right? All the module comprise the number of lexical tokens according to the predefined order. So the possible lexical tokens are byte space, commands, operators, numbers, strings, identifiers, and key module, right? So we have to design any program in a Verilog module by using Verilog HTL by using a module alone, right? So then again that we have to write the test bench. It is also start with the module. Later it can be called as a stimulus module or test bench. So this is the model for your module program, and module, it is nothing but it will be significance, the declaration of a module, and in here we are mentioning a test. In that we have to give a name to the particular module. For example, if you have to write the coding for a half adder, means we can give the name for a half adder, or a different name we can give it over here. And then here the statements 1, statement 2, right? So all the statements, what are the statements we have to use to over here? To be end with semicolon, and all the module will be terminated by end module, right? So the module will be start with module and it should be end with end module. So this is a procedure to write your program in your Verilog HDR. And this is one of a simple program for the by using NAND gate. So initially it will be start with module, right? It is a keyword, and next one is name we have assigned over here is it is NAND gate, and it is start with the open bracket and end with open bracket and semicolon. O is nothing but the output. Output we have only one port will be there, so it will be mentioned as O, and I1, I2, I3, I4 up to I8 will be there. It is nothing but the input leads. And then we have mentioned the statement 1, statement 2. It to be end with the semicolon, and to be end with end module, right? So the end module you didn't have any semicolon. So this is the basic syntax for your module. And next one is the test benches, right? So then the test benches we have to check and ensure whether all the function will be carried out as desired, right? So then we have to write the program and we have to test our program by using a test benches, right? So we have to apply a set of input over there, and we have to check it out whether we have to get the all the function sequence will be carried out as desired, right? So and here it is one of a test for the dynamic behavior of your circuit, test benches, right? And checking the timing behavior, and one test for the propagation and other types of delays here. So the variety of tests may be carried out over here. So it may be involve the observation of variation of signals at the selected points and time delay between specified events, pulse width, and so on, right? So initially the keywords, right? So keyword initial is followed by the sequence of statement between the keywords is begin and end, right? So usually we are using an initial keyword in the test benches, and then we have to use the begin as well as the end keyword also. Usually the initial banners, it is if you have start with the initial banner, it will be executed only once for all, right? So here we have to mention the hash 100. This is for a time delay, right, or a waiting time for the simulation. So initially has $100 finish. So it is nothing but initial means it should be executed only once, and hash 100 means it is a delay of 100 nanoseconds, and finish means your program will be end, right? So we have to apply this the test signal for our design circuit, right? So the language construction convenience, right? So we have a different construct as well as convenience help of the software language. So the Verilog has its own construct as well as a convenient, and it may be resembled sometimes in a C language also. So every Verilog source file is made up of number of ASCII characters. So the characters will be grouped and referred as a lexical tokens, right? Already, Verilog is a case sensitive language like C. So better you have to use any one of a character. For example, here the sense will be all should be in small letter, and here see here the sense, each and every the sense will be represented a different way. All will be here, take it as in the Verilog, it is a different one alone. So when you have to enter into a keyword, we have to very safe. It is because it is a case sensitive language. So up to which we have to discuss about the introduction of a Verilog students, and the next class we have to discuss about the remaining things. Thank you.